Hello everyone, welcome to Statistics with Alao Oluwafemi. In the previous video, we spoke about measure of central tendencies, that is the meaning of measure of central tendencies, the main measures of central tendencies, the mean, the mode, and the median. In the previous video, we spoke about the mean, the meaning of the mean, the types of the mean, and we had one or two examples to further showcase our understanding on the mean. We also discussed the alternative method in finding the mean, where we differ, or we talked about the assumed mean method. We also recognize that there are other methods for finding the mean, but just for that particular video, in order not to make it very long, we try to only speak or talk about the assumed mean method. We talked about random facts about the mean too in that particular video. So in case you didn't get to watch that first video, please ensure you watch the video before you move right into this. In this video, we will be considering the mode. We'll be looking at mode, the terms of the meaning, then few worked examples under the mode, and once again random facts about the mode. So once again, in case you are still there without writing materials, or you're still there sitting and wanting just to flow with the head, you are very wrong. So get your writing materials, and once again, let's flow together into this lesson. All right, now what is the mode? Mode is the most frequent value in a distribution. It is the highest point of the frequency distribution curve, the only measures of central tendency that can be used with categorical data. So for example, you are running a business and you want to understand what people are ordering or what people are getting more from your store. That's where mode comes in, because it has to do with frequent value in a distribution or in a data set, right? So maybe for example, to say in your shop, you are getting clothes, a particular type of clothes more. That's that particular type of clothes you want to restock back into your business, and this is what mode wants precisely. In a distribution, we can have unimodal, bimodal, trimodal, or multimodal. What does this mean? It means that we can have one mode, two mode, three modes, or more, right? But what people are most familiar with is unimodal. That is a distribution that has only one mode. I've even heard somebody say that, oh no, you can't have two mode in a distribution. Yes, we can have two mode, we can have three mode, we can have multiple modes in a distribution, right? But what has often been taught is unimodal. Also in this video, we'll only be considering unimodal distribution, that is a distribution with one mode. What are the advantages of mode? One, it is easy to understand and calculate, just like I rightly mentioned. Oh, come on, it has to do with the one that has the most frequent value in a distribution. Obviously, you don't want to stretch yourself on that. You have just gotten the answer. Once you observe that this is one that occurs more frequently in that distribution, you pick it and you move on, right? Easy to understand and calculate, just like I have said, the one that occurs frequently. Is not easy to pick? Very easy to pick, right? It can also be located conveniently. What does that mean? In a case of histogram, or in a case of bar chart, or in a case of any chart, you can find the mode, or even in a data set, just by inspection, you can understand that, oh, this is the mode, right? Because it shows what value is occurring most in that particular distribution. It is not affected by extreme value, that is outliers. No matter how big the value, it is not concerned by the mode. The mode is dealing with what is the one that occurs frequently in that distribution. In fact, it doesn't use all observations in the distribution or data set, and this can be a disadvantage for the mode, because we can't perform some algebraic calculations or mathematical manipulations with the mode. Why? Because it doesn't use all values in the observation. Also, it lacks uniqueness. That's another disadvantage. What do we mean by lack uniqueness? It means that just like I said, you can have more than a mode in a distribution. That is, you can have one mode, two modes, three mode, but so it doesn't lack, it's not unique. It lacks uniqueness. Or compared to the mean has just one value, and you don't have two means. But the mode, you can have one, you can have two, you can have three, as it may appear in the distribution. Also, the mode can be non-existent. What can that mean? As a mode is non-existent, It means that you can have a case where there is no mode present, that is, every number there appears equal time. You see, that even makes the mode even complicated, because how will you say the mode is not existent? So this is another disadvantage of the mode. All right, so up next we want to look at how do we obtain mode, right, from a distribution, be it grouped or ungrouped data. All right, now calculating the mode of ungrouped data is very easy. That is, all you just need to do is just observe that data and select the number that occurs frequently in that place. If you just check it and see this is the one occurring frequently, go for it. Now I need to also state clearly that there is difference between the largest value in a distribution and the one that occurs frequently. A small number in a distribution can occur frequently. That's the mode, right? The largest value is the one that is the biggest, so it's not the mode. It could be the largest value, but it's not the mode. So I've seen people often go and confuse mode to say that they are picking the largest value because the value is the biggest in there. No, it's not the same thing. The one that occurs most is what the modes want, right? Also for grouped data, it has formula, right? And this formula is simply as the lower class boundary of the model class plus change 1 over change 1 plus change 2. I know you are beginning to look at it as what again is change 1, what is change 2, right? No, don't worry. So the change 1 and the change 2 is just to ensure that this distribution doesn't look so clustered with different things, right? And to ensure that you try to make it look as attractive as possible for you, that you just kept puzzling in your mind what is change 1, what is change 2. All right, so now back to the question, what is change 1? Change 1 is simply the frequency of the modal class minus frequency before the modal class, and change 2 is frequency of the modal class minus frequency after the modal class. You can see it's just a way to just represent it so we don't cluster that particular formula times the class size says. However, the class size C. However, if you don't want to go through the route of this particular formula, there's also an alternative formula that you can work with, right? And the alternative formula is as this displayed on the screen. That is, if you don't like that change 1 and change 2, you can like this one. Then this is lower class boundary of the modal class plus frequency of the mode minus frequency before the modal class divided by frequency of the modal class minus frequency before the modal class minus frequency after the modal class times C. Bellumi, you will like this formula, right? So this is lower class boundary of the modal class, frequency of the modal class, as you have seen, as explained in this place, what all this thing mean in the formula. So either you use the one that has the change, or you use the one that has this one without the change. So the difference between this one is that one with the change, you just try to use change to represent such that we don't cluster the formula. So anytime you want to use that formula with change, you have to state what change 1 means, what change 2 means, right? But if you're using this particular one, there's nothing to state other than to just tell us the things that you have named in this particular formula. All right, so up next we want to take examples on mode. That is, when I have ungrouped data, how do I get the mode? When I have a grouped data, how do I get the mode? And as we can see, as displayed on the screen here, we have two different data sets, and then we want to find the mode of this data set. For this first man, the mode. Now, the mode in this place has helped us to see that we can get our answer as quick and straightforward as possible. What do I mean? Looking at the data set, see 32, 45, 45, 36, 24, 76. Which one appears more often? Very easy. It's 45. That's all. There's nothing to start stressing or killing yourself over. The answer is just 45. And you're done with that. You moved on away from that particular one. Up next, we want to go to the one that is the grouped data. How do we calculate the mode for grouped data? How do we calculate the mode for grouped data? Once again, we're employing the formula, right? And what's the formula? The lower class boundary of the modal class plus frequency of the mode minus frequency before over 2 frequency of the mode minus frequency before minus frequency after times the class size C. What's the first step in getting this? The first step is you want to go into the group data and determine which class has the highest frequency. That is, which class has the value occurring more or the class that is occurring more in terms of frequency. And if you observe from this group data, the class occurring more in this case is 61 to 70. 61 to 70. And what does this imply? This means that the 61 to 70 has 8 as its frequency, which is the highest of all the whole frequency that we encounter in this data. So hence, our class that we're working with is 61 to 70. What is the lower class boundary of this data? Yes, the lower class boundary is simply 60.5. How did I get 60.5? Simply subtract 0.5 from the lower class limit. So without wasting our time, we'll just go to inputting that. So this is 60.5. Then what is the frequency of the modal class? It's simply 8. What is frequency before the modal class? It is 7. What is frequency after the modal class? It is 3, as you can see in this place. After 3, before 7. What is the class size? The class size is 10. How did I get 10? 10. The class size is the subtraction along the upper class limit or along the lower class limit. That is 60 minus 50, 70 minus 60, 80 minus 70, or 71 minus 61, 51 minus 41, and the like. So, right? So you have 10. Now back imputing it into the formula. This is 60.5 plus the frequency of the modal class, that is 8 minus 7, just representing it directly as what is stated above. Then put into bracket, this is 8 minus, this is 7 minus, this is 3 times 10. Alright, so how do we go about calculating? This is 8 minus 7, this is, first and foremost, this is 60.5 plus 8 minus 7, this is 1 over 2 times 8, that is 16. 16 minus 7, that is 9. 9 minus 3, and this is 6 times 10. Again, Shola, what we are trying to say is that for you to be able to calculate this, you shouldn't go about doing 60.5 plus 1 over 6 times 10. That's a very wrong way to calculate. Rather, you start by saying 1 times 10 divided by 6, then add it to 60.5, or 1 divided by 6 times 10, then you add it to 60.5. Shola, don't go and do 60.5. Then you say you add the answer, you go to 1 over 6. Then you now multiply everything by 10. You're going to run into trouble. I'm saying it now. Okay, just say I didn't do something for you. Alright, so this is now 60.5 plus 1 times 10 will give you 10 divided by 6. That should give you 1.66667, and this will be equals to 62.2666. Yes, 62.166. Alright. Okay, so we can also go back to, that's for the first formula. You can also use the change formula. Precisely, we already stated what change 1 is and what change 2 is. In case you have forgotten, we said change 1 is frequency of the modal class minus frequency before the modal class, while change 2 is frequency of the modal class minus frequency after the modal class. So again, to use the formula, same step, determine which class has the highest frequency, then obtain the lower class boundary. Again, as we have calculated, the lower class boundary is 60.5. Then what is change 1? Change 1 is simply the frequency of the modal class minus frequency before, that is 8 minus 7, this is 1. Then again, change 1 down is 1, and change 2 is frequency of the modal class minus frequency after, that is 8 minus 3, and this is 5, and this is 5, then times 10. Again, as you can see, this is going to lead to 1 over 6 times 10, which will give us the same answer as above. Alright, so what are we trying to say in essence? You can see this one is looking more tidier than the one at the top. So, but regardless, whichever formula you want to go for, you still arrive at the same answer. So you can pick which one you're convenient with, either with the one with the change or the one that is as direct as possible. So this is the way we calculate mode for group data. And also, as discussed earlier, the one for ungroup data, what you just simply do is just to select which one occurs most in that particular distribution. All right, I hope you get that very correct. So by now I'm sure that you should be able to calculate mode of any distribution, either group or ungrouped data precisely. All right, we want to now look at random facts about the mode. What is the random fact about the mode? One, it is the only one usable for both quantitative and qualitative data. That is, I just stated it, mode can be used in every conditions, right? Because it just has to do with the one that occurs frequently in a distribution. So either quantitative or qualitative, mode is here for you. Now, two, the mode is 0 is not the same as no mode. You did get that? The mode is 0 is not the same as no mode. What it means is that in a case where you have everything to be balanced, that is equal, in such case there is no mode, right? That is, maybe they all occur equal number of times, no mode. Then when you are, because somebody is saying that, oh, the mode is 0, the mode is not 0, right? In the case where the mode is 0 is a case maybe when 0 occurs more in that particular distribution. Understand that 0 can also be a data on its own. So once again, brother Desire, when they all occur equal number of time, there is no mode in such case. All right, so it is not affected by outlier, as we have stated. There is nothing that concerns the mode with the highest value in that particular episode, the value that is the largest. Nothing opposed to mode. They just want to say which one occurs frequently in that particular distribution. Also, democratic voting system run entirely on the principle of mode. You don't know before, right? Yes, the democratic voting system runs entirely on mode. What does this imply? As Tinubu became the president is by mode. That is, the frequent number of time he was chosen, right? That is mode. That is, his party, APC, was coming up repeatedly across different polling units, and then he emerged as the president. So in democratic voting system, mode is often employed. Like, that's the principle of mode looks like. Also, business rely heavily on mode. I just stated that also. Like, for example, Pelumi is selling clothes, and then people kept getting a particular thing from that store, that particular clothes, and Pelumi wants to restock, or wants to do a kind of a restock for our business. I want to take the inventory. This case, the mode is preferred because you want to know exactly what people are ordering and what you should get, buy back into the particular store. You don't want to go and get something else that people are not ordering, right? Then this is something that is like an advantage for mode over the rest of the measure of central things. So once again, I want to believe that you have been able to understand what mode is, how to calculate the mode for grouped and ungrouped data precisely, and obviously the random facts has been able to help you know more better to understand mode. Up next, we'll talk about median. So make sure you stay tuned. Thank you.